Hi everyone, this video is going to investigate solving rational equations. In this situation right now we have 20 over x squared minus x minus 6 plus x over x minus 3 is equal to x over x plus 2. In order to solve this equation, what we can actually do is we can work towards finding a common denominator. And as we had discussed in class previously, once we have that common denominator all set and we've adjusted the numerator as a result, we can kind of ignore what's happening in the denominator and go straight into our solution. So to begin with, let's go ahead and take a look at the denominator of x squared minus x minus 6. And we want to know if we can factor this down. And you probably could use the other denominators that you see to help you figure out how to factor this. Or perhaps since you've been doing it long enough, you might actually have a good idea as to what it's already going to be. But just in case you don't, I'm going to go ahead and set up the box method over here on the left. And I can break x squared into an x times x. I'm going to take a look at my negative 6 here. And I know that since it's negative, one of the signs is going to be negative and one of the signs is going to be positive, because a negative times a positive will give me a negative value back. So if we go through our list of possible choices for multiplying two numbers to get 6, I would say, again, noticing over here that one of the numbers is a minus 3 and a plus 2, that might be more than a coincidence, so let's go ahead and see if that's going to work. So I'm going to opt to put in a minus 3 and a plus 2, and we can go ahead and do our checking here. So x times negative 3 gives us negative 3x, and then x times positive 2 gives us 2x. And again, I'm using that grid multiplication here. So if we were to add this up, we get a negative x back, which checks out. So let's go ahead and rewrite the problem now. So we're going to have 20 all over the quantity of x minus 3 times x plus 2 plus x all over x minus 3. And I'm going to intentionally leave a little bit of space so that when we're ready we can go ahead and write in that common denominator is equal to x over x plus 2. So recall from class from section 6.3 we were talking about finding a common denominator and basically making sure that the kids all have the same kinds of things in the denominator in order to make them happy. So in the first case, our first child has an x minus 3 and an x plus 2. Our next child has an x minus 3, but this child does need an x plus 2 in order to be happy. So we're going to multiply the top and the bottom by an x plus 2. If we come over here on the right-hand side of the equation, we notice that this child has an x plus 2, but is missing an x minus 3. So we're going to go ahead and multiply the top and the bottom by an x minus 3. So if you notice now, all of our denominators are the same. We have an x minus 3 times an x plus 2. We have an x minus 3 times an x plus 2. You have an x plus 2 times an x minus 3 over here, but please remember that the order for a multiplication problem does not matter. So x plus 2 times x minus 3 is the same thing as x minus 3 times x plus 2. So essentially what we can do here is, since our denominators are the same all the way through, much like any other problem where we dealt with fractions, we can ignore it now. So I'm going to go ahead and run a line through it and kind of pretend that I don't see it. So it's not that I'm canceling it out. That orange line is really just saying your eye doesn't need to go down there anymore. There's nothing that you can do with it. Okay, you've used the denominator in order to find what kind of numerators you should be working with. So in this case, we're going to have 20 plus x times x plus 2 is equal to x times x minus 3. So what I want you to note here is that I rewrote what I have in my numerator. Okay. But notice by ignoring the denominator, this allows me to actually go ahead and continue to work. So I'm going to go ahead and distribute my x's into the quantities. And this is going to give me 20 plus x squared plus 2x is equal to x squared minus 3x. So I've just distributed. The next thing that I might try is, well, I'll start combining like terms, but if I subtract an x squared from both sides, then it ends up canceling everything out, which is great. That won't always be the case. For now, where we are at in the course, it will, but as we get closer to chapter 8, we're going to have to come up with some other avenues. So now this gives me 20 plus 2x is equal to negative 3x. So I would say the best bet is that we should get the x's to one side, because we're solving for x, so we eventually want to get x all alone. So I'm going to subtract 2x from both sides. And this is going to give me 20 is equal to negative 5x. And we'll move that up so we can see a little bit better. All right. And then we'll go ahead and we will divide both sides by a negative 5. And this is going to give me negative 4 is equal to x. And what we always want to do is I would double check your denominators here. So if we were to rewrite the problem, so what I'm about to do is a check. What I have circled is my solution, so technically you could stop there. But if we come back over here and we put a negative 4x squared minus a negative 4x minus 6 plus negative 4 over negative 4 minus 3 is equal to negative 4 over negative 4 plus 2. So what I'm doing is I'm just double checking to make sure that my work is correct and accurate, that x really should be equal to negative 4. If that is the case, then I should get a true statement. So if we go ahead and evaluate here, we'll have 20 is all over, negative 4 squared is positive 16, negative 4 is going to make that a positive 4 minus 6, plus negative 4 over negative 7 is equal to negative 4 over negative 2. So we can do a little bit more cleaning up here, as you can see. It's a little bit messy. So we're just going to keep going, keep whittling this problem down. So move that up and leave it so that we can see our answer. So now this is going to give us 20 over 16 plus 4 is going to give you 20, but minus 6 is going to give you 14 plus, and since we have a negative over a negative, that would give us 4/7. Again, we'll have a negative over a negative, and we also have 4 over 2, which simplifies down to just a 2. Of course, I'm not done. Our check seems to actually be taking us a little bit longer than is expected, but you know, let's keep plugging away here. So 20 over 14, that's going to reduce. So I could reduce that down by 2, so that's going to give me 10/7 plus 4/7 is equal to 2, and well, it does that work? Well, since we do have the same denominator here, we're in luck. We don't have to find a common one. That gives me 14 over 17. My question to you is, does 14 over 17 simplify down to a 2? Yes, it does. So gold star, our solution of x equaling negative 4 is correct. Also notice, and this will be important if you move on to the next video, when I simplified down my denominators here, and we'll just put that over a 1 so that you can see, notice that none of the denominators ended up being 0. If they did, if any of your denominators ended up being 0, that would cause a problem. Remember, we have a huge, like, math mortal sin that says that your denominators can never be 0. So sometimes just doing a quick check in the denominator is going to save you some time and potential points, I guess, in this case. I hope this video was helpful. Please let me know if you have any questions or would like some additional feedback.